So good morning. So we are going to discuss about the design of ideal high pass filter with a frequency response. It is given by h3 of e power j omega is 1 for modulus omega varies between pi by 4 to pi and 0 for modulus of omega is less than or equal to pi by 4. And we need to find out the values of h of n for capital N equal to 11 and plot the magnitude response. So the first step in design of FIR filter is we need to find out Hd of n. That means we have to apply inverse Fourier transform to Hd of e power j omega to obtain Hd of n. So according to the inverse Fourier transform, the formula is Hg of n equal to 1 by 2 pi integral of minus pi to pi Hg of e power j omega into e power j omega n d omega. Now if you see the limits, so it is clearly given modulus of omega. Modulus of omega means the omega has both positive value as well as negative value. So when we see when you take the positive value of omega, it will be pi to pi by 4. When you take the negative value of omega, it will be minus pi to pi by 4. So that's why the limits here it is given as minus pi to minus pi by 4 e power j omega and d omega plus pi by 4 to pi e power j omega and d omega. Because omega is modulus of omega, one is with respect to the positive, another one is with respect to the negative. So for positive, the limit is pi by 4 to pi. For negative, the limit is minus pi by 4 to minus pi. So that is what it is drawn in this diagram and expressed here. Now after integrating it and substituting the upper and lower limit in this expression, you will be getting the final value as 1 by pi n sine pi n minus sine pi by 4 n. So this is the Hd of n expression you will be obtaining. After that, you need to substitute the value of n varies between 0 to capital N is 11, so 0 to 5 you have to do. That means you have to truncate the H3 of n to 11 samples. So H of n equal to H3 of n for modulus of n less than or equal to 5, 0 otherwise. So first you have to substitute n equal to 0. If you substitute n equal to 0, then it will be you will be getting the value as 0. So you are going to use the L dash hospital rule. According to the L dash hospital rule, limit theta tends to 0, sine theta by theta equal to 1. Also, limit theta tends to 0, sine n theta by theta equal to n. So according to those mathematical expressions, we have to use this L dash hospital rule here. So you know that the given formula is 1 by pi n sin pi n minus sin pi by 4n. So if you apply the L dash hospital rule in both the places, we will be getting limit n tends to 0 sin pi n by pi n is 1 minus limit n tends to 0 sin pi by 4n by pi n is 1 by 4. So 1 minus 1 by 4 it is 1 minus 0.25, it is 0.75 you will get as for n equal to 0. Then for n not equal to 0, that means for n equal to 1, 2, 3, 4 you have to use this formula. So in this formula, when you substitute n equal to 1, here it will be sine pi minus sine pi by 4 by pi. So you have to use your calculator in radian mode to calculate these values. So you will be getting the value as minus 0.225. Like that, we have to substitute n equal to 2, 3, 4, 5 and its symmetric 1, minus 2, minus 3, minus 4, minus 5. So you will be getting the value as for h of 2 as minus 0.159, h of 3 minus 0.075, h of 4 is 0, the value of h of 5 is 0.045. So after finding out this impulse functions h of 5, h of 1 to 5, 0 to h of 5, then your next step is you have to find out the transfer function of the filter. For the transfer function of the filter, we have the formula h of z equal to h of 0 plus summation n equal to 1 to n minus 1 by 2 h of n into z power n plus z power minus n. So in this, you have to substitute the h of n values already which we have found out. We have to substitute n equal to 1 to 5 and expand this. After substituting expanding in and substituting those values, you will be getting this particular expression. The next one is we have to find out the transfer function of a realizable filter. So in order to find out the transfer function of the realizable filter, we have the formula h dash of z equal to z power minus 5 into h of z. That means in the h of z expression, we have to multiply it with z power minus 5 throughout this equation. So after multiplication, we will be getting this above equation. From this equation, we have to write down the h of 0, h of 1, 2, 3 and all. So how we will be writing this? If it is z power minus 2 means the value associated is h of 2. Like that will be, and h of 2 is symmetric with h of 8, so that's why it is equal to 0.075. Similarly we'll be writing this. After that we have to find out the frequency response h of e power j omega equal to summation n equal to 0 to n minus 1 by 2 a of n cos omega n. To find out the a of n with respect to n equal to 0, the formula is h of n minus 1 by 2. To find out the other n equal to 1, 2, 3, 4, 5, we have the formula 2 into h of n minus 1 by 2 minus n. So after substituting these formulas, so we will be getting the a of 1, a of 2, a of 3, a of 4, a of value like this. Then when you substitute in these expression, we will be getting this equation as h bar of e power j omega is 0.75 minus 0.45 cos omega minus 0.318 cos 2 omega minus 0.15 cos 3 omega plus 0.09 cos 5 omega. Now in this expression we have to substitute the value for omega. For various value of omega you have to find out the h bar of e power j omega. So now with we have to keep this calculated in degree mode itself. For various value of omega, we are finding out h of e power j omega. The same thing we are doing in terms of decibels also. So here they have found out the values from each increment of 10. So it is not required to do the value to calculate the values in increment of 10. Even you can go for 0, 30, 60, 90, 120, 150, 180 like that in increments of 30 also. So when you plot the magnitude response, you will be getting the frequency